Okay, folks, so on Friday then we finished up talking about the measures of dispersion. So first off, what does a measure of dispersion do to a set of data? Measure of dispersion. Spread about the mean. How your scores are spread about the mean. The smaller your measure of dispersion, the more consistent your scores are, the closer they are to each other. The larger your measure of dispersion, the more widely spread they are, the least consistent as you get out further. What are the four measures of dispersion? Range. How do you calculate it? Max minus min. Second one? Mean absolute deviation. How do you calculate the mean absolute deviation? Summation of the absolute value of x minus x bar over n. Third one? Variance. How do you change the formula to get the variance? In parentheses, x minus x bar squared. So instead of taking the absolute value to make them positive, we're squaring them to make them positive, which also makes the numbers much larger. So how do we counteract that? By taking the square root of the variance, a measure that we call the standard deviation. So the mean absolute deviation, the variance, and the standard deviation, three very important formulas. To go along with then the measures of central tendency that tell us what about a set of data? Measures of central tendency, what do they do to the set of data? They summarize the set of data. What are the three measures of central tendency? The mean, the median, and the mode. How do we calculate the mean? Summation of all of our scores divided by n. Those are four must-knows, folks. Four must-knows. Now, these ones are all to find the population. What if they asked us to find a sample? Then we would go n minus 1 as opposed to n. Because it's not the whole population that you're taking into consideration. Okay? With the population, you've got to take every single score into consideration. But with a sample, are you using every single score? No, but you know how many scores you're using. You just know you're not using all of them. So you've got to divide by n minus 1. Because out of your 100 scores, you could be using 99 of them for the sample. You're just not using that one. So we're just going to divide by n minus 1 for the sample. Okay? Because it could be everything up to 1 minus n. Okay? Questions on those? Okay, let's take a look at the individual problems that we had then on page 994. We had divisible by 3 on both sets, right? Again here, folks, do you need to show formulas on these? What am I going to give you on your homework if all you've got are the numbers written down? I'm not going to give you credit. I'm not going to give you credit for these. The range, there's a calculation you've got to show. Mean absolute deviation, a calculation you've got to show. Variance, standard deviation, there are calculations you've got to show on these. So if all you've got are the numbers, you're not getting credit for these homeworks, folks. Number 3 is a range of 19. 6 is a range of 0. 9. A is 15 and B is 18. I think it's a mean of 15 and an absolute deviation, I believe, of 18. I think that's what they're asking for on those two. 12. 12 is true. 12 is true because we're taking the absolute value of them. 15. They gave you 3 sets of data and you needed to find the range, the mean, and the mean deviation for all 3 of them. Well, all 3 of them had a range of 5. All 3 of them had a mean of 4. Set 1 had a mean deviation of 1.4. Set 2 had a mean deviation of 1. Set 3 had a mean deviation of 1.8. Part B, they were asking which set was the most consistent. Well, set 2 was the most consistent. Set 3 was the least consistent. So set 2, set 3. Set 2 was the most consistent. Set 3 was the least consistent. 18 I don't care about. I'm only concerned with 3 through 15 on the first page. Don't worry about 18. Questions then on 3 through 15? Questions 3 through 15? 15? What's your question on 15? Okay, so Derek, it's just how you read the data that they're given there? Okay. What this means then is we have a score of 1, a 2, 3, 3, 4, 5, 5, 5, 6, 6. So Derek, if they were to write that out then for you, your set of data would be 1, 2, 2 3s, a 4, 3 5s, and 2 6s. Okay, so it was just reading the data then? Okay. You're comfortable with calculating everything on? Okay. Other questions we've got here? Okay, let me give you the answers to the next page then. These ones were also divisible by 3, right? Number 3, a mean of 3, a standard deviation of 1.4. 6 has a mean of 187, a standard deviation of 3.3. 187. 9 has a mean of 4, standard deviation of 3.1. And 12, they told you the standard deviation was 2.5 and wanted to know what the variance would be. What do we have to do to the standard deviation to get the variance? We have to square it. Yeah. The standard deviation is the square root of the variance. So if we know the standard deviation, we square it to get the variance. So 2.5 squared is 6 1/4, or 6.25. Questions here? Number 6. Number 6, the heights in centimeters of 5 basketball players on the team are listed at the right. So we've got these heights, and for these heights we need to find the mean and the standard deviation then on number 6. So again, first off here, to find the mean, how do you calculate a mean? X bar equals sigma x over n. Okay, so here we've got it. And then part B, they ask for the standard deviation. So let's get everything set up before we have to go into the calculator. Well, before we can find the standard deviation, we first have to find the what? The variance. So how do we find the variance? Sigma x minus x bar squared over n. And then the standard deviation is the square root of the variance. So what are we going to equal up here? The numbers to equal, and then the square root of that. Now are we all set for the calculator? Yeah. Into the calculator, where do we go? Stats. Edit. So how do I get these values out? Yep. Highlight the column, clear enter. Highlight the column, clear enter. What are the scores we have? 192, 189, 187, 184, and 183. What's the most important thing to do now? Double check them. I've got a 183, a 184, 87, 89, and 192. Do we have them entered correctly? Yes. Okay, so now, from the home screen, how do we calculate sigma x? Sum, where do we get sum? Second stat, math 5. We want the sum of what? Sum of L1. They add up to what? 935. How many of them were there? 5. 935 divided by 5 gives us 187 is our average. 187 centimeters. The variance. How are we going to get sigma x minus x bar squared from the calculator? How do we get sigma x minus x bar squared? Sum again, so I'm just going to hit second enter. So I got sum without having to go through it again. But sum what? Not absolute value. Another parenthesis. L1 minus the 187, close, square, close. So we've got x minus x bar squared, and we're adding them all together to give us what? 54 that we are going to divide by 5 to get what? Yep, 10.8. And now what are we going to do with that 10.8? Take the square root of it. They wanted us to the nearest tenth. What's the square root of 10.8 to the nearest tenth? 3.3. Staying 3.3 or rounding up to 3.3? Rounding up to 3.3. Folks, do I have anything up there that is not necessary? Nope. To get credit on your homework, that's what you need. You've got to have the formula, you've got to plug them in, and you've got to sub them through. Okay with 6? Find your mistake on it? Okay. Anything else, folks? What's that? Number 9? Okay, so did you get your average correct? Number 9 had an average of 4, so your average is correct. Okay. So I'm what did you get for your standard deviation? Okay, so somewhere along there it was just so you just got a wrong sum when you added them up. Okay. Yep. So it was just something to calculate then with adding them up then. As long as your mean is correct, and Shelby and anybody, that would just be a 1-point error. I mean, you know your formula. You've shown me your formula. You just it was a button pushed somewhere. And if your mean was right, that tells me you entered all the numbers in correctly. You just found that summation wrong. Okay. Anything else, folks? Okay. Tomorrow we are going to have a quiz on measures of central tendency and the measures of dispersion. I'm going to tell you exactly what your quiz is going to be here, folks. Question number 1. What does a measure of central tendency do to a set of data? You will answer it by telling me. Summarizes. Question number 2. What are the 3 measures of central tendency? You will tell me. Mean, median, mode. Question number 3. What does a measure of dispersion do to a set of data? You will tell me. Shows how the scores are spread about the mean. What are the 4 measures of central tendency? You will tell me. Range, variance, standard deviation, and mean absolute deviation, or mean deviation. Question number 5, I will give you a set of data. You will have to calculate all 7 values. Okay. Quiz tomorrow, okay, on those 7 values. Okay. Moving along today, we're going to focus strictly on grouped data. And there's 2 things we're going to be looking at with our grouped data. And when we were looking for mean, median, and mode, we dealt with some frequency data where we put our scores into L1, and then where did we put our frequencies? Into L2. So we're somewhat a little bit familiar with how we're going to handle these frequencies, but now it's really going to be focusing on the measures of dispersion with these frequencies as well. Okay? So we know how to calculate all 7 of these measures. We just now need to tweak the formulas slightly to take into consideration frequencies. Okay. Each score is not going to be represented just once. Okay. You're going to have multiples of these scores, and how are we going to take them into consideration then? There's 2 ways to handle this. Number 1, you can ignore the frequencies and type all your scores, those multiple times, into L1. Is that going to be a lengthy process, though? Yeah. You might have one score that occurs 8 times. Well, you're going to have to type that score in 8 times into L1. Another score might occur 15 times. You're going to have to type it in 15 times into L1. Number one, it's long. Number two, you're leaving yourself wide open for a lot of error. Because then you've got to go back and double check that you entered that one score 15 times. That other score 8 times. So that's not the best way to handle it. Okay, we're leaving ourselves up with a lot of error if we're going to enter each score those multiple times. What we want to do, we want to enter the individual scores into L1 and their corresponding frequencies into L2. So again, where do we always put the scores anyway? L1. So we're still putting the scores into L1. We're just putting their corresponding frequencies now right next to them in L2. And now what we just have to do is slightly adjust the formulas. We've got to make those formulas now accommodate these frequencies that we're plugging in. And there's only 4 formulas. We've got the formula for the average, the formula for the mean deviation, the variance, and the standard deviation. So we just want to see how they're going to be tweaked to take care of this frequency. And again, when we were looking at the measures of central tendency, we already knew how we were going to take care of the frequency with our scores. We didn't just add up our x's, but we first had to multiply our scores by what? The frequencies. So we took our scores times the frequencies, added all those up. And that's how it's going to be. Every one of these formulas is just going to get changed by multiplying by a frequency. It's just where do we multiply that frequency into? So again, scores go where? L1, frequencies go L2. Scores into L1, frequencies into L2. And now it's just adjusting those formulas then. So what I've got provided here for you then are the formulas that you'll have to write on a paper. And then what we're going to do right next to them is explain how it needs to be done in the calculator. So in black, we are going to have the formulas that need to be written down on paper. And then right next to them in red, we're going to explain how we have to do this. So this is what you just told me. To find the mean, we've got to take each of our scores and first multiply them by the frequency and divide by n. Okay? But up here, this is how we put it into the calculator. Again, where do all of our scores go? Our scores go into L1. Our frequencies go into L2. And that n that we're going to divide by, that represents, again, what? The total number of scores. Well, how are we going to find our total number of scores? By finding the sum of our frequencies. The sum of our frequencies are going to tell us how many scores we've got. Okay? So basically what we need to do, folks, is go into these formulas that we already know, and wherever there's an x, we have to replace it with what to go to the calculator? L1. Wherever there's an f, we need to replace it with what to go into the calculator? L2. And wherever there's an n, it needs to be replaced with sum of L2. Okay. So these right here are the formulas you must provide for me. These need to be written down on the homework. These need to be written down on the quizzes. These need to be written down on the Regents exam. You will not get credit. These are the formulas that must be written down. And then right next to them in red, we're going to show how we're going to calculate them in the computer, or in the calculator. So the average, again, we're adding all of our scores and dividing by the total number of scores. But we've got frequencies, so it's the scores plus their frequency, or times their frequencies. Okay? So in the calculator, how would we get this summation of f times x? Well, in the calculator, this symbol is what? Sum parentheses. X is going to get replaced with L1 times f gets replaced with L2. It's just the sum of L1 times L2 That will tell us what all of our scores add up to. And then n, the total number of scores. How will we find the total number of scores? That's the sum of L2. Now what I have written there in red, is that what you write down on your paper? No. That means nothing to a grader, folks. If you're going to put the red on the paper, you are not showing the grader anything. You're going to say, well, what's L1, what's L2, what are they doing? You've got to show this. Summation of the frequencies times the scores divided by however many are. This is how you calculate it. Okay, so then you would get this number divided by this number to give us our average. Okay. The mean absolute deviation, again, sigma in the calculator is what? Sum parentheses. Now how did we get this absolute value? Absolute value, which gives us another parentheses. What do we put inside the absolute value parentheses? L1 minus the average. Close it. What's that? Not yet. We still have to take these deviations and multiply it by L2 times L2. Now close the sum. Each one of these deviations, they don't occur just one time. They occur however many times they're in the frequency. So each one of these distances needs to get multiplied by however many times it occurs. Then we will add them all up. And then again, divide by the sum of L2, which will give us one number divided by another number to give us our mean absolute deviation. It's just an understanding of what our variables represent in the calculator. Are we going to change that very much to get this one? Instead of taking the sum of the absolute values, we're now going to take the sum of just simply parentheses again, L1 minus X bar, close, square, times L2. Close the sum off. Again, we've got to take our deviation, but this time we're squaring it. But each one of those distances then needs to be multiplied by however many times it occurs. And then we will add them all up, and again divide by n, which is sum L2. So that's our variance, and then again here, folks, to get our standard deviation, we're still just taking the square root of what? The variance. Nothing changes there. Once you find your variance, so we type in that, beat that, divide by that, equals our variance. Then we take the square root of our variance to get our standard deviation. Okay, so we just got to multiply them by L2 now. Okay, we're just multiplying those values by L2 before we close off the sum. Okay. This here was sum L1. Well, now it's got to be sum L1 times L2 before we close it. This used to be just sum of the absolute value. Well, now we got to multiply by L2 before we close it. This used to just be the sum of the squares. Well, now we've got to multiply by L2 before we close it. Okay? So it's just that multiplying by the L2, or by your frequency. Again, do you show me the red on paper? What do you show me on paper? The black. The black is what needs to be shown on paper. The red is then how we do that calculation in the calculator. Okay? Quick example then. Okay, you don't need to get the example written down. We'll just go through the parts A and B together then here. Okay. What do they want me to find in part A? A mean. So for part A, what is our formula? How do we find X bar when there are scores and frequencies? Summation of what? X, our scores, times our frequencies divided by n. Part B. What do you want me to find in Part B? Well, I can't find a standard deviation unless I first find the variance. How do we calculate the variance when there's scores and frequencies? Not absolute, not for variance. How do we calculate the variance, folks? Sum of what? Nope, no. That's what we do in the calculator. Parentheses, minus x bar, close, squared, times our frequencies, divided by n, and then the standard deviation is simply square root of v. Are we all set now to go calculator? Yep, turn them on. How do we clear out values that are already in there? Highlight your column, clear enter. What goes into the first column? The scores. So we've got 20 to 80 going by 5. So 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75, and 80. What do we put in the corresponding column in L2? Frequencies, we've got 1, 2, another 2, a third 2, 14, 28, 36, 34, 27, 23, 11, 3, and finally 2. What's the most important thing to do now? Yeah, we want to double check. If we're one value off, we're throwing the whole thing off. So you double check as I say them. 82, 75, 3, 70, 11, 65, 23, 60, 27, 55, 34, 50, 36, 45, 28, 40, 14, 35, 2, 30, 2, 25, 2, and 21. We all good? Okay, back to our home screen now that everything's entered in correctly. Okay, how do I type in this formula? What does this formula represent in the calculator? How do I get sigma? Second stat, math, 5. What do we want the sum of? What does x represent? L1 times, what does f represent? L2. My scores all add up to 9960. N, what does the n represent? Sum, so I'm just going to hit second enter. We just want the sum of what though? L2, so let's delete the L1 and the times. What does L2 add up to? So there was 185. Divide those out for me. What's 9960 divided by 185? We'll go to, what do they want here? Nearest hundredth. Nearest hundredth is how many decimal places? 2. 53.84. 53.84 is our average. 53.84. Have I shown any unnecessary work there? Nope. All the work we've shown is necessary. Okay. Variance. How are we going to calculate this? What does this mean in the calculator? Sum. I'm just going to hit second enter again. Well, we want the sum of what? Another parentheses. X is L1 minus, what's x bar? 53.83. Close. Square times L2. Close. Okay, so what does the top add up to? And are we going to round that? Absolutely not. What do we need to round? Yeah, the final answer. The standard deviation is what we need to round, not this. 19,575. Point what? Point what? 126? Okay. Folks, you got to understand that you're talking to the screen, not me. 1465. Over, again, our n is still going to be what? 185. So our variance then, we're going to take that value, divide it by 185. 105. 811 6027. And now what are we going to do with that value? So the standard deviation is the square root of 105.8116027. We want this one to the nearest hundredth as well. 10 point what? 28 or 29? Yeah, nearest hundredth. 29? 10.29 would be our standard deviation. Okay, again, folks, did we show anything that was in red? No. If we're going to show this stuff that's in red, are you going to get credit for that? No, we've got to show the formulas in the black, and then the red is how we type them into the calculator. So I've shown a formula, I've substituted into that formula, calculated it. Shown my formula, substituted into the formula, calculated it. Showed my formula, substituted in, calculated it. Anything that I've shown here that I don't need to. Everything is a must if you're going to get credit. Everything is a must. Folks, statistics are easy. It's all done in the calculator. You just need to know how to do it in the calculator. You've got to know the formulas. Okay? And then let the calculator do its job. The second thing we need to deal with frequencies are score intervals. Instead of them just telling me the score and how many times it occurs, they're going to give me a score range and tell me how many scores fall within that range. Okay? So I don't know individual scores. I know a range of scores. I know that I've got two scores that fall from 96 to 100. I have four scores that fall from 91 to 95, so on and so forth. So do I have a specific score to be able to enter into L1? We don't. And we sure cannot enter a range of scores in L1. We can't put 96 to 100, 91 to 95. We can't do that. What are we going to do with that score range then to get a score that would represent that whole range? How would we find a score to represent the 96 to 100 interval? How would we get a score to represent the 91 to 95 interval? What would be a good representative score of that interval? Get the average of it. You're going to average your two endpoints. 96 plus 100 is 196. 196 divided by 2 is 98. So for that 96 to 100, what will we be entering into the calculator? 98. For 91 to 95, we will be entering in 93, 88, 83, 78, 73, 68. If they give you an interval of scores, you have to average your interval out. And that's the score that goes into L1. And then is it any different? No. Nothing different after you do that. So if they give you an interval range, you can't enter that interval into the calculator. You actually need a score. Well, get a representative score then for that interval. Average your two endpoints. And that average score will represent that interval. Okay, so when we go to the calculator here, what will we put into L1 for our scores? Which are what? 98, so let's go in. Stat at it. Again, how do I get these cleared out? Clear enter. Clear enter. So what's the 96 to 100? 98, 93, 88, 83, 78, 73, and 68. What are the corresponding frequencies? 2, 4, 10, 14, 10, 6, and 4. Okay, which is why we go back and do what? We go back and double check. 68, 4, 73, 6, 78, 10, 83, 14, 8, 10. I've got a goof. What's that supposed to be? It's supposed to be an 88. So 88, 10, 93, 4, 98, 2. Are we correct now then? Yes. Okay, so second, quit. We'll move back to the home screen. What are they asking us for in part A? A mean. Okay, what's our formula? How do we calculate a mean adjusted with frequencies? X bar equals sigma x times f divided by n. Part B, what are they asking for? Well, we can't figure out a standard deviation until we know a what? Variance. So how do we find that variance? Sigma x minus x bar squared times f divided by n. And then how do we find the standard deviation? Square root of the variance. Folks, I've still got 3 minutes here. I don't know why we're all packing up. How do we now go and calculate this one? Sum L1, what did you say? Times L2. What do they add up to? 4,100. Now they automatically told us here, how many scores do we have? 50. So what do we get? What's 4,100 divided by 50? 82. We've got an average of 82. How are we going to compute this one? So again, sum, a new parentheses, L1 minus 82, close, square, times L2. 2,800 divided by 50, we have a variance of 56. And now what are we doing with that 56? Nearest hundredth. 4/8. Rounding up to an 8 or staying an 8? Staying 8, 7.48. Okay. We just got to show those formulas, folks, and just have to modify them to the frequencies. Will frequencies be on the quiz tomorrow? No. You will not have frequencies on the quiz tomorrow, just the normal calculations. Okay? So you don't need to worry about frequencies on the quiz tomorrow. You've got to know your formulas and you've got to know your 7 measures and what they do. Okay, page 1013, we've got 1 through 15, the odds. Folks, again, you're not going to get credit for just putting a number down. What do you have to show me? Formulas, subbing in, and solving. 1013, 1 through 15, the odds.